welcome to Statistics with Ava. This is Ava with an A, not with an E. I'm cool. We'll be talking about section 7.3. I wrote on a whiteboard because I'm prepared. No, I'm not. This is why I am making this video in my dining room. Section 7.3 is about sampling distributions and just sample means. Actually, it's not about sampling distributions. It's about sample means. So, what does a sample mean? That's a really good question, which is why I have my statistics book right here. I don't remember things. That lead paint chips, they're getting to me now. The mean of a sampling distribution is the same as the mean of a population. That's crazy. So here's the thing. So here is the population, and here is the sample population. Population, this is population, X. This is sampling population, X bar. These two means are equal because you're just taking a sample out of the population, so it is assumed that the means will be the same unless you're really bad at taking samples. Perfect definition would be if you took a sample, it would just be the population graph, but it would be smaller. So, which is kind of dumb because it's not how samples work in real life. So I don't know why you would do that. So if you're taking a sample standard deviation, which is this, so these two things are definitely not equal because again we said that it's smaller, so obviously your standard deviation is going to be smaller. So they probably are just like, oh, how can we make this smaller? So we're dividing it by the square root of n. What is n, you may ask? I think you should know what n is by now. So if I had a bunch of bees in a hive and I was like, okay, we're going to count the number of stripes that all these bees have and see how many stripes an average bee has, because there's nothing better to do, right? 5 bees out of this hive, and we're going to say 15. So I have 15 bees here, so that's the number of bees that I have. So say there are 200 bees in the hive, but you take your standard deviation and you're going to divide that by the square root of 15. Not the square root of 200 bees. No. You want your sample n. That's what you're going to divide your standard deviation by, and you're going to get your sample mean, standard deviation. That's what that is. This. My graphics are very helpful, obviously. Bees. 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 I love bees. Because, if we didn't have bees, we would all be dead. So, save the bees. Hashtag save the bees. Queen Bee. Beyonce. We all love Beyonce. We all love bees. Because we don't like dying. If your population distribution is normal, then your sampling distribution will be normal. If you pay attention to the 20 bees. Because if you don't follow the 10% rule, then your whole thing is messed up. So follow the 10% rule. 10% rule, if we need a review, is that n, your sample n, must be at least 10% of your population number. So our 10% rule is one of the conditions, right? So we have another one. Yay! Okay, so the central limit theorem, or the CLT as we like to call it, which is just a boring VLT, pretty much. So the central limit theorem, instead of calling this chapter sample mean, they should call it conditions for a, that's why they didn't call it that, it's way too long. So that's where it should say conditions for a significance test for a sample mean. Yeah, that's why they didn't call the chapter that. Okay, well, anyways, 10% rule, number 1. CLT, boring BLTs, what is a CLT? So this stupid textbook right here gives me a dumb definition, and it says that if your n is a large number, then you're fine and your distribution is normal. If it's large, what kind of definition is that? So we're just gonna go by this rule of thumb. And we're going to say that if n is bigger than 30, you're good. You're fine. So, you know, with like proportions, how it's like you have to do the whole, your proportion times n, it has to be bigger than 10, and then 1 minus your proportion. We don't need to do that here. You just have to make sure it's bigger than 30, and you're all set, my dude. Population is already normal, then you're good to go and you don't really need the CLT. But if your distribution is not normal, say you have a skewed distribution, such as this one, and you would like it to look like this, then that's not even skewed. What am I saying? Like that. Then that's when you'd use the central limit theorem. Yeah, so that's basically it.